Hi friends, in this video we are going to discuss about one problem which is very important. So that is this problem, which is basically based on the chain rule properties of the Jacobian. So here chain rule properties of the Jacobian says, so here just observe one thing, u is the function of x comma y. Here u equal to e to the power x cos y and v equal to e to the power x sin y. Here therefore u is the function of x comma y. Therefore u comma p is the function of x comma y, and x is defined as lr plus sm and y equal to mr minus ls, where l and m are constant. Therefore r and s are variable. This says that x and y is the function of r comma s. In the same way, y is again a function of r comma s. Here u is the function of u comma v is the function of x comma y, and x is the function of r comma s, and y is again a function of r comma s. According to chain rule property, u comma v is the function of r comma s, and so through x and through y, that is u comma v is the function of r comma s through x and y. So here verify the chain rule properties of Jacobian being l comma m are the constant. That means we have to show Jacobian of, we have to show that is here we have to show Jacobian of u comma v with respect to r comma s, which is equal to here u comma v with respect to x comma y into x comma y with respect to r comma s. That is here Jacobian of u comma v with respect to x comma y into Jacobian of x comma y with respect to Jacobian of this is r comma s. This is my, so that's I have to show. So here I want to show Jacobian of u comma v with respect to r comma s is same as Jacobian of x comma y with respect to u comma v into Jacobian of x comma y with respect to r comma s. That is here u to r is same as u to x plus x to r. So here u comma v is the function of r comma s, and r comma s is the function of, sorry, x comma y is the function of r comma s, then u comma v is the function of r comma s. That's we have to show. Therefore here u comma, we have to show u comma Jacobian of u comma v with respect to x comma y plus into Jacobian of x comma y into r comma x is same as Jacobian of u comma v with respect to r comma s. That's we have to show. This is the chain rule properties of your Jacobian. So here again I will explain. So here u comma p is the function of x comma y, x comma y is the function of r comma s. Here there u comma v is the function of r comma s in the same way through x and y. So here this is the, so how to prove is the following. Now in the starting, here u is the function of x comma y and v is the function of x comma y, that is clearly given. So first find the Jacobian of u comma v with respect to x comma y, because here it is already given u and v as a function of x comma y in terms of x and y variable. So here first I will find Jacobian of u comma v with respect to x comma y, and in the same way x and y is defined in terms of variable r and s. This is in terms of r and s. So here we can find Jacobian of x comma y with respect to r comma s. So here after that first find right hand side. So here I will find, since given here given u equal to e to the power x cos y and v equal to e to the power x sin y. This is my given information, and here with x equal to, so let's say with x equal to lr plus sm and y equal to, so here write given information mr minus ls. This is the given information. So first I will find Jacobian of u comma v with respect to x comma y. So u is the function of x and y, v is the function of x and y. So here I will find Jacobian of u comma v with respect to x comma y. So here that is u x u y v x and v y. So first I want to find ux. So here ux which is equal to partial derivative of u with respect to x being y as a constant. So here e to the power x into cos y and partial derivative of u with respect to y. So here derivative of cos y is minus sin y, here minus e to the power x, this is sin y. In the same way I want to find vx and vy. So here vx which is equal to e to the power x into sin y, here vy equal to derivative of sin y is cos y. So here e to the power x into cos, this is y. Now, so therefore Jacobian. So therefore here Jacobian of u comma v with respect to x comma y, which is equal to, now just put the value of ux. So here e power x cos y, here uy, this is minus e power x sin y, vx, this is e power x sin y, e power x, this is cos y. So determinant of this, that is product. So here this into this minus this into this, which is equal to e power 2x. So here this is cos square y minus minus plus e power 2x into sin square y, which is equal to e power 2x times cos square y plus sin square y, which is equal to e power 2x, this is 1, which is equal to e power 2x. So this is my Jacobian of u comma v with respect to x comma y. So here first, here just now I have found I get Jacobian of u comma v with respect to x comma y. Now the x and y is defined in terms of r comma s variable. So now I will find Jacobian of x comma y with respect to r comma s. After that I will find Jacobian of u comma v with respect to r comma s, left hand side. So here now, so first given x equal to, so here since x equal to L R plus S M and y equal to, this is M R minus L S. So therefore now I want to find Jacobian of, so here I want to find Jacobian of x comma y with respect to r comma s. So here r and s are the variable and L comma M are the constant. So here which is equal to, so here which is equal to x r and x s and y r and y s. So partial derivative of x with respect to r, partial derivative of x with respect to s, first row, partial derivative of y with respect to r and partial derivative of y with respect to s is my second row. So therefore I want to find xr, xs. So here I want to find xr, which is equal to partial derivative of x with respect to r. So here partial derivative of this function with respect to r. So here L r plus Sm. So this is constant. So this is simply L, and partial derivative of x with respect to s. So here this term is completely constant. Now Sm with respect to s, this is simply m, and partial derivative of y with respect to r. So here this is my mr minus ls. So this is complete constant. So here this is simply m, and partial derivative of y with respect to s, which is equal to minus l. So here this is my constant term. Now here how to find, so I think most of the students are confused. So here this is my x equal to Lr plus Sm. So partial derivative, so here partial derivative of x with respect to r, which is equal to, so here L is constant, partial derivative of this function, so here which is equal to, in the simple way, partial derivative of this function with respect to r, which is Lr plus Sm, which is equal to, so here L is constant, so by properties of addition, so L into partial derivative of this function with respect to r plus partial derivative of this function with respect to r, Sm. So which is equal to L times partial derivative of r with respect to r is 1 plus partial derivative of s and m, both s and m are constant, partial derivative, so derivative of constant is 0, this is equal to 0, which is equal to L. So here in this way we can calculate. So here, but it is not possible to write each and every step. So here, so this is my xr, xs, yr and ys. So therefore Jacobian of x comma y with respect to r comma s, which is equal to, so here xr is, so here this is my L, this is my m, So this is my m and this is my l, which is equal to minus l square minus m square, which is equal to minus in bracket. Here I will take minus common, l square plus m square. So here this is my Jacobian of x comma y with respect to r comma s. Therefore the product right hand side, therefore right hand side, here right hand side equal to, so here Jacobian of u comma v with respect to x comma y into Jacobian of x comma y with respect to r comma s. So here which is equal to Jacobian of u comma v with respect to x comma y is e to the power, this is e to the power 2x, and Jacobian of x comma y with respect to r comma s is here minus in minus, here this is minus into, so here l square plus m square, which is equal to minus here. So directly minus into e to the power 2x plus l square plus m square. This is my Jacobian of, here this is my right hand side, x comma y with respect to xy, sorry uv with respect to xy into xy with respect to rs. So this is my right hand side. So here I will, somewhere I will write my right hand side. Now I want to show my left hand side is also equal to this quantity. So here this is equal to my right hand, so now I want to show my left hand side equal to this. So this is my right hand side. So somewhere I will write my right hand side. So after that I will start answer again. After that I will start writing answer again from this step. So here first I will write, so all of you know, I hope please pause and write this thing. Now I will again start my answer from this step. So here now I will write here my right hand side. So this is my given information. I need to find the Jacobian of u comma v with respect to r comma s. So here please pause and write. So here I need right hand side in future. That's why here I will write my right hand side equal to, here right hand side equal to minus e to the power 2x times here l square plus m square. So here this is in bracket term. So here this is not the part of solution after this step. So here this is my right hand side. So here my right hand side is this. Now I want to find left hand side. So but in the starting just observe one thing. U is the function of x and y. So here v is the function of x and y, and x is the function of rs, and y is again function of rs. But while finding the, so I want to find the Jacobian of u comma v with respect to r and s, but I want to write u and v in, so in terms of r and s variable. So here I want to write my u and v as a r and s variable. So here u is the function of x and y variable, v is the function of x and y variable. I want to write this u and v in terms of r and s variable. So here u equal to, so here I will write this x equal to, just put this value, x equal to lr plus sm into cos of, here the value of y. So value of y is mr minus ls. Now just observe one thing. U is the function of r and s. So here l and m are constant. So r and s are the variable. So here this exponential function is the function of r and s, and this cosine function is again a function of r and s. So the product of these two functions is again a function of r comma s. So u is the function of r comma s. In the same way I want to write my phi equal to, so here in terms of r and s, e to the power lr plus sm into sine of mr minus ls. So now I want to find Jacobian of u comma v with respect to r comma s. Therefore now I want to find left hand side equal to, here left hand side equal to Jacobian of u comma v with respect to r comma s, which is equal to, so here first row corresponding to u. So u r, u s, v r, and this is v s. Here r and s are the variable. Now I want to find u r, us, vr and vs. How to find is the following. Therefore I want to first find ur. So here ur equal to, here I need more space. So here I will write from here. So here I want to find ur. So here u r partial derivative of my function u with respect to r. So here partial derivative first as it is into derivative of second, and second as it is derivative of first. So here first I will write e to the power here l r plus s m as it is derivative of my second. So here derivative of this function. So derivative of cos is minus sign. So here minus sign times here this is minus sign of here m r minus this is l s into derivative of angle with respect to r. So this is simply m plus, so here second as it is, that is cos of m r minus l s into derivative of first, that is derivative of this e to the power l r plus s m into derivative of exponent, this is l. So here I will write this as which is equal to minus m times, which is equal to minus m times e to the power, here I want to write this same function in short form again. So here the value of x equal to, so the value of x equal to lr plus sm, I want to convert u in terms of r and s, that's why here I am writing in place of x lr plus sm. So I want to write this step in short form. Here I will write x equal to, so x equal to lr plus sm, so in place of lr plus sm I will write this is x, and to sign of here mr minus ls I will write this is simply y here plus, so here this is l into here e to the power here lr plus sm, here I will write x, and to cos of, so this is y. So here this is my u r. Now I want to find u s, here partial derivative of this function u with respect to s. Therefore in the same way first as it is e to the power l r plus s m as it is derivative of cos function with respect to s. So here this is minus sine of mr minus l s derivative of angle mr minus ls with respect to s. This is my minus l plus second as it is. So that is plus here cos of mr minus ls as it is cos of mr minus l s as it is into derivative of exponent, that is e to the power lr plus s m into derivative of lr plus sm with respect to s. This is simply m. Again in the same way here I will write this as here this minus gets plus, this is simple l e to the power this is x sine of this is y plus this is m times e to the power x, this is cos of y. Now this is my us. So here this is my us. Now I want to find vr and vs. So here I want to find vr and vs. So here partial derivative of v with respect to r which is equal to, so where is my v? So here first as it is v to the power l r plus s m into derivative of sign is cos. So here cos of here m r minus l s derivative of angle with respect to r, this is simply m plus second as it is, that is sine of here m r minus l s as it is derivative of first e to the power l r plus s m into derivative of exponent with respect to r. So this is simply l. So in the same way here again I will write this is equal to vr equal to, so m times e to the power x cos of y plus l times e to the power x sine of this is y. Now I want to find vs. So here this is my vr, I want to find vs. So here vs equal to same way e to the power l r plus s m into derivative of derivative of second. So here cos of here m r minus l s. Now this time with respect to s. So here derivative of angle with respect to s. This is my minus l plus sine of here plus sine of m r minus l s here m r minus l s mr minus ls into derivative of first. So e to the power lr plus sm with respect to s. So here with respect to s, that is m, which is equal to, so here which is equal to, so here this is minus l e to the power x into cos of y plus, so here this is m e to the power x, this is sine of y. Now I want to take so therefore just put the value of left hand side equal to Jacobian. So here therefore, so this is my Vs, therefore left hand side equal to Jacobian of u comma v with respect to Jacobian of r, so with respect to r comma s, which is equal to, so here just put this value in this determinant. So ur, where is ur? Ur equal to this, so here minus m times e to the power x sine y plus l e to the power x times cos y. So us, so here us is l e to the power x times sine y plus m e to the power x times cos y. Now vr, so vr is this m e to the power x cos y plus l e to the power x sin y into vs minus l e to the power x cos y plus m e to the power x sin y. Now just take the determinant. So here first I will take e to the power x common. So here this is equal to e to the power, here e to the power x from first row, e to the power x from second row, so e to the power 2x times. So here again after that I will find the determinant. So here which is equal to, here first bracket, big bracket, so product of these two things, e to the minus e to the power x, sorry, e power x is already take common. So here minus m times sin y plus l times cos y. This is my first bracket into second bracket. Here, so here this minus into minus becomes plus. So here I will write this is minus l cos of y plus m, this is sin y. So here you can take minus minus common. Okay, no, so this is minus, yes. So this is my first bracket. So here minus m e to the power x sin y plus l e to the power x cos y. So here e power x already take common, minus m sin y plus l cos y minus l cos y plus m sin y, my first bracket, minus, so here which is my first bracket. So here this is big bracket. So here with minus sign, so here second bracket for this. So here this is l e power, sorry, l, this is l sin y plus m cos y into, so here into, so here this m cos y plus l, this is sin y. So here this is big bracket and this is whole big bracket. So here which is equal to, so here e power 2x big bracket. Now first solve this two bracket. So here minus m sin y into minus, so here this is minus minus plus, this is ml. So here sin y, this is cos y, this into this minus m square sin square, this is sin square y. Now plus this into this. So here this is minus l square cos square y and minus minus, so sorry, this is plus l m, this is sin y and this is cos y. Now I want to multiply this second bracket also. So here this is my first bracket here. Now I want to multiply my second bracket also. This is minus sign here, minus l, so here minus l sin y into m, here this is plus, sorry, l m, this is sin y cos y plus here this into this L square, this is sin square y. Now this into this, so here this is plus m square, this is cos square y, this into this, so here this is L m, this is sin y into cos y, so here big bracket. Now here multiply this minus sign to throw out this bracket, which is equal to e to the power 2x big bracket, so here m L sin, here sin y cos y, so here m L sin y cos y, here minus m square sin square y minus L square cos square y plus L m sin here y cos y. Now here I want to multiply this here with minus sign, so this is minus L m sin y cos y minus L square sin square y minus m square here cos here square y minus L m sin here y, this is cos y, and this is my whole bracket. Now just observe one thing, this is Lm sin y cos y, this is minus Lm sin y cos y, this cancel this with this, so this is plus Lm sin y cos y, this is minus Lm sin y cos y, this is cancel with this, so here the remaining term, so here minus m square sin square y minus L square cos square y minus L square sin square y minus m square cos square y. So here I don't have space, so here I will write the same step over here, which is equal to, so here which is equal to here e to the power 2x in bracket, here m minus m square sin square term minus L square, so here I will take so here minus L square minus m square into sin square y, so here this is minus L square minus m square into, so here I will take this is sin square y, and this is where is cos square, sorry, so here, so this is equal to, wait, this is sin square term, so here I will take sin square term common from here, I will take cos square term, yes, okay, this is equal to e to the power 2x times, so here minus L square minus m square, here I will take sin square common from here, sin square y. Now here this is minus L square and this is minus m square, so here in the second step, here I will take this is minus L square minus m square into here cos square y. Now sorry, directly here it is given, how it is here, this is not possible, yes, so here which is equal to, which is equal to e to the power 2x times, so here wait, this is m square, and here I will take m square common from this two things, so here I will take minus m square here common, so here if I take minus m square common, so this becomes sin square y plus this is cos square y, now it's okay. Now here I will take minus L square common, yes, so here I will take minus L square common from these two things, so here this is minus here L square into, so here cos here minus L square, this is cos square y plus this is sin here square y, so here which is equal to here e to the power 2x in bracket, so here minus m square sin square y plus cos square y is 1 minus L square sin cos square y plus sin square y is 1, which is equal to here e to the power 2x times this is minus m square minus L square, which is equal to, I will take minus common from this, e to the power 2x times L square plus m square, which is equal to right hand side. So here therefore this is my right hand side and left hand side is already found, right hand side equal to this is my left hand side, therefore right hand side here, therefore left hand side equal to right hand side. That is here left hand side is, this is my left hand side, minus e to the power 2x in bracket l square plus m square, which is equal to right hand side we have find, which is equal to minus e to the power 2x times l square plus m square. That's we have to show. This is the so with this property we can, so here we have to show, this is my chain rule properties of the Jacobian. So if u is this, v is this, and x is this, and y is this, u is the function of x and y, u comma v, and x comma y is the function of r comma s, then Jacobian of u comma v with respect to r comma s is same as Jacobian of u comma v with respect to x comma y into Jacobian of x comma y with respect to r comma s. So here left hand side, so from left hand side I will show in part. So here this is my left hand side first part. Here left hand side is completely right hand side is minus e to the power 2x l square plus m square, and after that I will write u and v in r and s variable, and I will find the Jacobian of u comma v with respect to r comma s. This is equal to minus e to the power 2x times l square plus m square. So therefore left hand side, this is left hand side equal to the right hand side. So here most of the time in exam maybe they will ask about so verify the chain rule properties of the Jacobian. So with the help of example verify the properties of Jacobian. So maybe they will ask one question. So I hope all of you understand. So please pause and write. So thank you.